good to see you all. Welcome to day 2 of the APCSA PD with PopViz. Today we'll look into loops, while loops, for loops, and nested loops. Before we head to today's topic, did you have any questions? Yeah, day 1 assignment was a lot, but the questions were not that difficult, right? So let's do a quick review on the last assignment from yesterday. Let's read the question. So we're going to create a method that returns the tip amount. Jean gives 18% tip when she eats out. Create a method called calcTip that has public access, takes a cost as a parameter, and returns the 18% tip amount. So if we were to pass in 12 to calcTip method, it should return 2.16. If we pass in 8, it should return 1.44. So let's begin. So this method, calcTip, is going to be public, and it will return a double value. So let's put double, and let's give it a name, calcTip. Then we need the parentheses, and inside it, we're going to pass in a double value, and we'll call it cost. Okay, now inside this method, we're going to return the tip amount, which is going to be 18%, right? That is cost times 0.18 and semicolon. Before we run the code, let's take a quick look at the input values that we'll be getting. So these are the dollar amounts or the cost that will be passed in. So $10.50, $8.50, $100, $0, $9.15. And let's run the code and see what our results are. Looks about right. Okay, so let's submit and check our answers. Great. Back to the slides. Yesterday, Stephen asked me a really interesting question, and I thought I should demonstrate this very briefly before jumping into today's topics. So Stephen's question was, what's the string args in the main method for? Did your students ever ask you this? A simple answer is that you can pass in string array as an argument to your main method, like you can do with any other methods. So the first thing Java looks for when we run the program is the main method. And when you're using an IDE, you probably haven't had the chance to do this. So I'll show you how the values are passed into the main method the old-fashioned way. So I created a Java file with this code inside, which uses a for each loop to print out the elements in the args array. Let me pull up my terminal program, and I'm going to cd into the directory where the file is. Here I am. Then I'm going to compile the Java file using the command javac. The file name is helloworld.java. Done. Then I'm going to run the program and pass in a few words so that it's stored in the args array. Java, hello world, and here are the words: apple, pine, porcupine. Once I run this, we should be able to see these words printed out line by line. And there we go. So the string args in the main method is used when you have to start your program with values passed in. And that's it. Let's get to today's lesson. Now let's explore loops. The first loop we will look at is the while loop. While loop reads like a sentence. While this condition is true, do this. So what will happen if we run this code? Take a look. The code will output small over and over again until the system crashes. This is called the infinite loop. Integer x is set to 2, and it'll always be less than 3. There is no instruction in there that will change x value to something else. So it'll always meet the while loop condition. In order to stop the loop, we need to control it somehow. Let's look at this example. This while loop keeps track of how many iterations it'll loop using the counter variable. And for every iteration, meaning for every loop, it'll update the counter, incrementing it by 1. Then stops when the condition is no longer met. So once counter becomes 5, we exit the loop. What is the output of this code? I'll give you 8 seconds. The answer is 0, 1, 2, 3, 4 printed on a separate line. You may find that some of your students have put down 5. This means that they'll need more practice with code tracing. Let's trace the code step by step. One way to trace the code is by creating a table to keep track of the variables. Well, there's no right way of creating the table, but here I have the columns in the order of the code. So we'll keep track of the counter at the condition, then track the output, and track the counter when it is updated. So the counter starts at 0, and 0 is less than 5. So we now have entered the while loop. Output at this point is 0, because counter is 0, and counter is incremented by 1. Now let's check against the condition again. Counter, which is 1, is less than 5. So at this point, 1 passes the condition. Output is 1. Counter updates, and it is 2 now. Going back to the condition, 2 is less than 5. It meets the condition, and the output at this point is 2. And counter updates to 3. And we check against the condition again. 3 is less than 5. So output, counter is 3. Counter is updated to 4. Once again, we check against the condition. 4 meets the condition. 4 is less than 5. And output is 4. Counter is 5. And we check against the condition again. And when counter is 5, we no longer meet the condition, so we exit out of the loop. And this is our output. Here is another example of the while loop. Here we have a video game of Wizard of Oz. The main character, Dorothy, has to go on a quest to help her friends find the wizard and finally meet the White Witch of the South. Then she can get back home. A player will keep playing the game until the quest is successful. And if the quest is not successful, this player will continue to play on and on and on. So let's look at the code. First, we have a status variable called quest success, which controls the while loop like an on-off switch. We set this quest success to false to begin with. And next, have a while loop which will run while quest success is equal to false. There are 2 ways to express this. So one is what you see here, quest success equals false. The other is not quest success, meaning the opposite of quest success is true. Inside the while loop, there's a method called to go on quest. This method returns a Boolean value of whether the quest was successful or not, then assigns its value to quest success. And for every iteration of the loop, we check whether quest success is updated. When go on quest returns true, then quest success is true, and the condition is no longer met. So we exit the loop. Finally, print the last 2 statements. There is no place like home, and the end. Note that in this case, we didn't know how many iterations it would take for the player to be successful. So while loops are useful for these kind of cases where the number of repeats isn't set. Next, let's explore for loop. For loops are used when we know how many times we need to repeat. Here is a while loop. Let's turn this into a for loop. But first of all, let's explore what this does. Here's a question. How many times will this print, "There is no place like home"? I'll give you 5 seconds. Yes, it is 5 times, where I will increment from 0 and then go to 1, 2, 3, and 4. There are 3 things to note here. In order to control exactly how many times this while loop will iterate, 1, we need the counter variable, I, the condition for the while loop, which is I is less than 5, and an updater, so I++. In for loop, instead of having the counter variable, condition, and updater scattered in different lines, for loop has them nicely organized inside a parentheses, separated by semicolons, like this. So both while loop and the for loop will print there's no place like home 5 times. Next, let's look at a very important concept, scope. We learned in day 1 that the curly braces define a code block. The variables declared or introduced in that code block is only valid within that block. This might sound vague, so let's look at an example. Here we have a for loop. What will happen if we run this code? Take a look. It will throw an error. Java does not recognize the variable n. That is because it is being called outside of its scope. Once the scope of that variable ends, so when it hits that closing curly brace, Java garbage collector will throw out the variable and it's no longer referenceable. So let's fix this code. The variable declared or introduced in that block is only valid within that block. So we need to declare n outside of the for loop so that last line's n is referenceable. Declare integer n above the for loop, like this. Now n is declared 1 level above the for loop. Then its value is set in the for loop. Now the last println will output 3 without an error. Note that the output is 3, not 2, because n incremented to 3 and then was no longer able to satisfy the for loop condition and had to exit. So at the end of the for loop, n is 3. Here is the full code and the scopes. Note that there are 3 different levels of the code blocks here. One at the class level, one at the main method level, and one at the for loop level. And the variable created in a block is referenceable within that block. So integer n created in the main method is referenceable within the main method block. Nested loops. Nested loops are a loop inside a loop. As you can see here, there are 2 for loops. One for loop is inside the other. Think of them as a clock. So the outer for loop is like the hour hand, and the inner for loop is like the minute hand. For every hour, the minute hand must go all the way around the clock to update the hour hand by 1. Let's trace the loops and see what the output is. The outer for loop has a loop counter variable I. The inner for loop has a loop counter variable j. For every I, inner for loop will make full iterations. In order to follow what's happening with the nested loops, it's useful to keep track of the variables using a table. So let's track I, j, and output. Here we go. I starts at 0, and for every I, j will make the full loop cycle. Remember, the minute hand must go all the way around the clock for the hour hand to update. J starts with 1. The output is 0, 1. We're not done with the j loop, so let's update j. J is now 2. And the output is 0, 2. J updates to 3. And the output is 0, 3. J updates to 4, and it no longer meets the condition, so we exit out of the inner for loop. Now that we've completed the inner loop, let's update I. So I becomes 1, and once again, we need to loop through the inner loop. And J starts at 1, and the output will be 1, 1. J updates to 2. The output is 1, 2. J updates to 3, and the output is 1, 3. J updates to 4. We no longer meet the inner loop condition. So we get to update I to 2. And once again, J starts at 1, and the output is 2, 1. J is updated to 2, so the output is 2, 2. J is updated to 3, so output is 2, 3. When J is updated to 4, we exit out of the inner loop. And I is updated to 3. Now we no longer meet the conditions for the outer loop. 3 is not less than 3. So we are done. And the output will look like this. So that's it for today, and tomorrow we'll cover classes and objects. Let me know if you get stuck or have any questions. Have fun coding, and I will see you tomorrow.